The river was cold in mid-April. The water temperature in eastern Ukraine at this time of year runs between 8 and 12 degrees Celsius, cold enough to create serious physiological risk for extended immersion, cold enough to impair motor function and judgment in ways that make demanding physical work underwater genuinely dangerous. The Ukrainian combat divers who entered the water that night understood this. They had trained for it. And they crossed the river anyway, because on the far bank there was a Russian pontoon bridgehead that had taken Russian engineering troops several days to build, and that was scheduled to support the crossing of heavy armor the following morning. It did not support anything. By the time the first light of a mid-April dawn touched the river, the bridgehead was gone. Charges placed in specific positions along the pontoon structure had detonated in sequence, collapsing the sections from their anchor points, sending two Russian armored vehicles that had been pre-positioned on the bridgehead into the river, and reducing several days of Russian engineering work to floating debris that the current was already carrying downstream. This is the story of how a small group of Ukrainian combat divers crossed a cold April river, destroyed a Russian engineering achievement, and returned home before anyone on the Russian bank fully understood what had happened. The intelligence picture that preceded the operation began with Ukrainian observation of Russian engineering activity on the far bank of the river over the preceding week. Ukrainian reconnaissance drones, conducting surveillance of Russian rear area logistics movement, had flagged the movement of bridging equipment, the same heavy trucks carrying pontoon sections, the engineering vehicles, the anchor and cable systems that characterize a planned river crossing operation, toward a specific point on the river where the bank geometry and water depth made a pontoon bridge feasible. Ukrainian analysts had assessed the location as a potential crossing point weeks earlier during routine terrain analysis. The confirmation that Russian engineering troops were moving toward it elevated the site to priority surveillance status. Over the following days, Ukrainian drone operators maintained observation as Russian engineering troops began construction. The bridgehead, a hardened approach ramp, and a platform structure designed to hold vehicles awaiting crossing, was built first, before the bridge itself. This sequence is standard Russian engineering procedure. Establish the near-bank infrastructure before beginning the water crossing construction, so that when the bridge is complete, vehicles can immediately begin moving onto it. The bridgehead took 3 days to construct to the point where Russian engineers assessed it was ready to support vehicle loading. Ukrainian analysts watching the construction understood its operational significance. A bridgehead of this scale, capable of holding multiple armored vehicles simultaneously in a staged queue for crossing, indicated that Russian commanders were planning to move a substantial armored force across the river at this location. The bridge itself, when completed, would enable that movement. Destroying the bridgehead before the bridge was complete would not only eliminate the infrastructure investment, but would disrupt the vehicle staging sequence that the crossing operation required, forcing Russian engineers to rebuild before crossing could begin. The decision to use combat divers rather than artillery or drones for the bridgehead destruction was deliberate. Artillery fires against the bridgehead, while potentially effective, would reveal Ukrainian knowledge of the construction and would prompt Russian commanders to accelerate their timeline or relocate the crossing point. FPV drone engagement of the bridgehead structures would face the challenge of destroying load-bearing pontoon and ramp structures that require specific demolition placement to collapse, not the kind of precise structural demolition that a single FPV warhead achieves reliably against complex engineering structures. Combat divers, approaching underwater, could place charges at the specific structural points that engineering analysis had identified as most critical. The anchor points, the junction between sections, the load-bearing elements whose failure would initiate a progressive collapse of the entire structure. The route analysis for the crossing was conducted with specific attention to the April River conditions. Mid-April river levels in eastern Ukraine are elevated from snowmelt and spring rains, and the current is correspondingly stronger than later seasonal periods. This creates both a challenge and an advantage for combat dive operations. The stronger current requires more physical effort to cross and to maintain position during charge placement, but it also carries acoustic and visual concealment. The river noise masks swimmer sounds, and the surface disturbance from the current reduces the visibility of any swimmer-generated surface disturbance that Russian perimeter security might otherwise observe. Ukrainian combat divers entered the water in the pre-midnight hours, using the maximum darkness period that mid-April conditions provide. The entry point was upstream from the bridgehead, allowing the divers to use the current to assist their approach to the target rather than fighting it. They moved underwater for the final approach, using the low light and thermal concealment that submersion provides against the Russian observation assets covering the river corridor. The bridgehead approach from the water side faced specific security challenges. Russian engineering operations maintain perimeter security that covers approaches from the river as well as from the bank. A bridgehead under construction, with valuable equipment and personnel concentrated at a fixed location, is a recognized target, and Russian commanders take precautions accordingly. The security coverage that Ukrainian intelligence had mapped during the surveillance phase included observation posts at the bridgehead's water-facing edges and periodic patrol of the near bank area. Ukrainian divers navigated to their charge placement positions using the underwater geometry of the bridgehead structure, the anchor chains, the pontoon hull undersides, the submerged support elements, to stay below the observation threshold of the surface security. Charge placement was conducted in sequence, working from the farthest structural point to the nearest exit point, so that the divers were always moving toward their extraction route rather than working past placed charges in the direction of travel. The charges were placed at the structural anchor points that Ukrainian engineers had identified as critical to the bridgehead's integrity. The anchor connections that held the floating sections against the current, and the junction points where the ramp structure connected to the floating platform. Engineering analysis of the bridgehead design, conducted from drone observation of the construction process, had identified these specific points as the locations where demolition would most reliably initiate progressive structural failure, rather than isolated local damage. Destroying an anchor point releases the tension that holds a pontoon section in position, and a pontoon section that begins to move under current load takes adjacent sections with it in a cascade that requires only the initial failure to propagate. The divers extracted before the charges fired, moving downstream with the current, maintaining the underwater approach that had gotten them to the target and that would get them back across the river before the detonations occurred. The extraction required more physical effort than the approach, moving upstream against the current for the final crossing back to Ukrainian-controlled bank, in water that had been cold enough to begin affecting fine motor control during the charge placement work. They made it. The current record of the operation includes the confirmation that all personnel extracted successfully before the charges initiated. The detonations occurred in pre-dawn sequence, the charges firing in the order that would maximize progressive structural failure, each detonation adding to the load on the adjacent structural elements that the previous one had stressed. The anchor failures released the pontoon sections to the current. The current did the rest. The sections began to move, taking the ramp structure with them, the entire bridgehead rotating and fragmenting under the combined force of the demolition damage and the river load it was now carrying without its anchor restraint. The two Russian armored vehicles on the bridgehead platform, pre-positioned for early loading when the bridge was completed, went into the river with the structure. One was recovered from a shallow area downstream over the following days. The other settled into a depth that made recovery impractical. By the time Russian security personnel on the far bank fully understood what had happened, the bridgehead that had taken 3 days to build was gone. The dawn revealed floating debris, 2 missing armored vehicles, and a riverbank where a significant engineering installation had existed the night before. Now let us examine what Russia lost. The bridgehead infrastructure destroyed by the Ukrainian combat divers represents an engineering investment of approximately $2 to $4 million USD in materials and specialized equipment. The pontoon sections, the ramp structures, the anchor systems, the engineering vehicles, time and fuel. All of this must be replaced before a crossing at this location can be attempted again. The 2 armored vehicles lost with the bridgehead add $3 to $5 million in vehicle replacement costs. The recovered vehicle may be repairable, reducing this figure, but the vehicle in the deeper water represents a total loss. The engineering personnel time lost, 3 days of specialist bridging troops working to construct an installation that was destroyed in a single night, represents an operational cost that extends beyond materials. Russian bridging specialists are finite in number and high in demand along a front that features multiple river obstacles. 3 days of their time invested in a destroyed installation is 3 days not available for other engineering requirements. Most significantly, the operational timeline disruption cost Russian commanders the crossing opportunity they were building toward. The armored force that was scheduled to cross the following morning must now wait for reconstruction. In mid-April conditions, reconstruction of a comparable bridgehead will take additional days, days during which Ukrainian forces can improve their defensive preparations on the far bank, days during which the operational opportunity that Russian commanders were trying to exploit may close as Ukrainian defensive posture strengthens. The total direct and operational cost of this engagement, accounting for materials, vehicles, personnel time, and operational delay, $15 to $25 million USD equivalent in lost capability and investment. Ukrainian combat divers crossed a cold April river with demolition charges. They placed those charges at the specific structural points that engineering analysis had identified. They extracted before the charges fired. The bridgehead was gone before dawn. 3 days of Russian engineering work? 1 night of Ukrainian combat dive operations. No bridgehead, no crossing. The river in eastern Ukraine flows past the debris of Russian engineering ambition. Ukrainian combat divers made it so. And the far bank, and the Ukrainian bank, is still defended, still held, still waiting for the next attempt that Ukrainian forces are already preparing to defeat. Ukraine goes where Russia does not expect. Ukraine destroys what Russia builds. Ukraine holds the banks of its own rivers. To fully understand what this operation represents, it is necessary to examine the specific capabilities that Ukrainian combat dive operations have developed and why this type of mission, demanding, dangerous, conducted by a small number of highly trained personnel against a target that conventional fires could not efficiently destroy, is a component of Ukrainian military capability that receives far less attention than it deserves. Combat diving as a military discipline requires a specific combination of physical capability, technical training, and psychological profile that makes qualified operators genuinely rare. The physical requirements are demanding: sustained exertion in cold water, the ability to manage the physiological effects of cold immersion on fine motor function and judgment, the underwater navigation and buoyancy management skills that allow precise movement in low visibility conditions, and the strength and endurance to work effectively with demolition equipment while submerged. The technical requirements include military diving systems, underwater demolition procedures, and the structural engineering knowledge required to place charges for maximum effect against specific target types. The psychological requirements are perhaps the most selective. The ability to operate calmly and precisely in an environment that is inherently hostile to human function, with no immediate support available if something goes wrong. Ukrainian military has developed combat dive capability through its special operations structure, units that recruited specifically for this combination of physical, technical, and psychological profile, and that have been training and operating throughout this conflict. The mid-April river crossing operation was not their first. Ukrainian combat divers have been employed against Russian logistics, infrastructure, bridge structures, and engineering installations throughout the conflict, building the operational experience that makes each successive mission more effective. The cold water dimension of this specific operation deserves examination beyond the general acknowledgement that April river water is cold. 8 to 12 degrees Celsius is a temperature range at which human body heat loss in water is rapid. At these temperatures, an unprotected swimmer loses consciousness within 1 to 3 hours. Ukrainian combat divers in this operation were using appropriate thermal protection equipment, but that equipment creates its own operational challenges. Added buoyancy that must be managed, reduced tactile sensitivity that complicates precise charge placement, and the physical bulk that makes movement through complex underwater structural environments more demanding. The charge placement work, attaching demolition charges to specific structural elements of a pontoon bridgehead while submerged in moving water in low visibility conditions with cold-affected fine motor function, is among the most technically demanding activities that military demolition operators perform. The anchor point attachment procedures, the timing sequence programming that ensures the detonations occur in the order that maximizes progressive structural failure, the management of the demolition cables or wireless initiation systems in a water environment. Each of these is a technical procedure with consequences for the entire operation if executed incorrectly. Ukrainian combat divers completed all of them under operational conditions. The intelligence support for this operation extended beyond the drone observation of bridge construction. Engineering intelligence, the analysis of the bridgehead structure to identify the specific anchor points and junction elements that demolition placement should target, required technical expertise that translated drone observation imagery into a demolition plan. Ukrainian military engineers who conducted this analysis were working from partial observation of a structure that they could not physically inspect, inferring internal structural details from external observation and from knowledge of Russian standard bridging equipment and construction procedures. The demolition plan they produced was precise enough to achieve the progressive structural failure that the post-operation observation confirmed. The detonation sequence, charges firing in order rather than simultaneously, reflects an understanding of structural failure mechanics that goes beyond simply placing explosives and initiating them. Simultaneous detonation would create simultaneous local damage at multiple points. Sequential detonation creates a failure cascade where each detonation adds load to the structure weakened by the preceding one, amplifying the total damage with a smaller total charge weight than simultaneous detonation would require. Ukrainian engineers who designed the demolition plan were applying structural engineering principles to maximize the effect of the charge weight that combat divers could practically carry across the river. The Russian engineering troops who built the bridgehead were qualified professionals executing standard Russian military bridging procedures. The construction over 3 days was methodical and competent. The bridgehead that resulted was assessed by Ukrainian observers as capable of supporting the vehicle loading requirements of the planned crossing. The security coverage they maintained around the construction site met standard procedures for a fixed engineering installation. They could not have known from within the constraints of standard Russian security practices that Ukrainian surveillance had built a precise picture of their construction and that a combat dive team was preparing to cross the river at night. This is the information asymmetry that enables Ukrainian special operations. Not superior numbers, not better equipment in every category. A more detailed picture of the target and a more specific plan for its destruction, derived from the intelligence investment that Ukrainian military has made in persistent surveillance of Russian operations. Russian engineering troops built a bridgehead. Ukrainian intelligence watched every day of construction and identified the specific vulnerabilities. Ukrainian combat divers exploited those vulnerabilities at the moment of maximum Russian investment and minimum Russian awareness. The armored force that was scheduled to cross the river the following morning is still on the Russian-controlled bank. The timeline for reconstruction is days at minimum. Ukrainian defenders on the far bank have those days. They are using them. The mid-April water of the river in eastern Ukraine is cold and flowing. Ukrainian combat divers crossed it in the dark and came back. The bridgehead they crossed to reach is gone. The armor that was going to cross it is still waiting. Ukraine sends its operators where conventional fires cannot reach. Ukraine destroys what Russian engineers take days to build. Ukraine holds the banks of its rivers with the specific understanding that the best time to defeat a Russian crossing is before it begins. The river flows, the bridgehead is gone, the Ukrainian bank holds. Consider what this operation communicates to Russian engineering commanders planning future river crossing operations in eastern Ukraine. Not through any official statement or deliberate messaging, but through the simple fact of what happened. Russian engineers can build. Ukrainian forces can find what they build, reach it through whatever means the situation requires, and destroy it before it can be used. A bridgehead takes days. A combat dive operation takes one night. The engineering investment, the specialized equipment, the personnel time, all of it can be eliminated by a small group of trained Ukrainian operators who cross the river in the dark and place their charges where analysis has told them the structure will fail. This knowledge, that fixed engineering installations in Russian-held territory adjacent to river crossings are reachable by Ukrainian forces, changes how Russian engineering commanders plan and execute. More security at crossing sites means more personnel at fixed locations that Ukrainian fires can target. More concealment means slower construction that takes longer to complete. More frequent position changes mean less time for construction to progress. Every adaptation that Russian engineers make to reduce their vulnerability to operations like this one adds friction and delay to their construction timelines. The Ukrainian combat divers who crossed the cold April River are not a large force. They are a small, specialized capability that imposes costs on Russian engineering operations far out of proportion to their numbers. The bridgehead they destroyed cost Russia 3 days of construction and millions of dollars in materials. It cost Ukraine one cold river crossing. That exchange ratio is why Ukraine invests in this capability. That exchange ratio is why Russian engineering commanders in eastern Ukraine now plan their crossing operations with the awareness that the river is not as secure as the bank. Ukraine crosses what Russia thinks it controls. Ukraine destroys what Russia builds with confidence. And the Ukrainian bank of every river in eastern Ukraine is defended by soldiers who know that holding it begins before the first Russian vehicle tries to cross. There is one more dimension of this specific operation that deserves examination: the relationship between the combat dive mission and the broader Ukrainian defensive concept for river obstacles in eastern Ukraine. Rivers are among the most significant terrain features on the Eastern Front. They are natural obstacles that channel movement, require engineering investment to cross, and provide defensive depth that infantry positions alone cannot replicate. Ukrainian defensive planning along the Eastern Front has incorporated river obstacles into a layered defensive concept that uses the rivers not simply as barriers to Russian movement, but as engagement opportunities. Locations where Russian crossing attempts concentrate force and resources in ways that Ukrainian fires can exploit. The decision to destroy the Russian bridgehead rather than allow the crossing to begin and engage Russian armor mid-river reflects a specific phase of that defensive concept. Ukrainian commanders have options at each stage of a Russian river crossing: disrupt the engineering preparation before construction is complete, destroy the bridgehead before vehicles load, engage vehicles during the crossing, or defeat the assault on the far bank after vehicles have crossed. Each phase has different costs and different effects. Destroying the bridgehead before vehicles load eliminates the crossing attempt without the risk of some vehicles completing the crossing and establishing a foothold on the Ukrainian bank, the scenario that presents the most difficult tactical problem for Ukrainian defenders. It also imposes the maximum engineering reconstruction cost on Russian forces, since the entire installation must be rebuilt rather than the partial damage that a mid-crossing engagement might produce. And it does so at a moment when Russian forces are maximally invested in the attempt. 3 days of construction completed, vehicles staged, crews ready, creating the maximum disparity between Russian investment and Ukrainian cost to eliminate it. Ukrainian combat divers were the instrument for achieving this effect because they could reach and destroy the bridgehead structure in a way that no other available capability could achieve with the same reliability and the same precision. They were the right tool for the specific phase of the defensive concept that Ukrainian commanders had decided to apply. Understanding this, that the combat dive operation was not a special mission for its own sake, but a specific instrument chosen for a specific phase of a deliberate defensive plan, is the key to understanding what the Ukrainian military has become after years of developing its capabilities in exactly this conflict. Every capability serves a role in an integrated defensive system. The combat divers exist not because they are impressive, but because there are specific operational problems that they solve that no other capability can solve as effectively. The bridgehead is gone. The crossing did not happen. The armored force is still on the wrong side of the river. And Ukrainian defenders on the far bank have additional days to prepare for the attempt that Russian engineers are now rebuilding toward. Ukraine uses every capability it has developed for the specific moment when that capability is most decisive. Cold April water. Combat divers. One night. A bridgehead gone before anyone on the Russian bank understood what had reached it from the river. Ukraine fights smart. Ukraine fights precise. Ukraine holds.